So I thought it might be good to dig into pandas a little bit more. And I'm going to make a new project. Oop, wrong one. And so the object here will be just to play around with pandas and get a better understanding of it. And the tutorial I'm going to use is W3 Schools has a series of tutorials on this. And so let's see, I wanted, this is not pointing to what I had before. Yes, right here under W3 Schools, if you search under Python, you'll find this pandas tutorial. And you can probably just go and look for W3 Schools pandas, and it'll bring you here. And so I'm just going to, you can reference this either while you're doing the demo or you're following along with me, or you could just go here and and go through these exercises. And I think it'll help with this library. So I'm going to create a new file. And let's just call this one something tricky, like, I don't know, demo1 pandas.py. And in this one, we're going to, let's see if that works. I'm going to run that. Okay, so it looks like it has access. I think what I'm going to do, though, is I'm going to go ahead and make a I'm going to make a requirements file. And we want pandas, so I'm going to put that in here. And then in here, I'm going to make a virtual environment. So that would be, by the way, I don't remember all these commands, so I look them up. So to make a virtual environment, I'm going to say Python -mvenv, and I'm just going to call it virtual venv. So that makes my virtual environment. You want to select this for the workspace folder? I'm going to say yes. And then I'm going to activate my environment. So venv script activate. If you're trying to, just to kind of give you an idea of what that is, it's actually running this. So I'm just putting in from pandas demo. We're going into the venv library to the scripts library. Scripts library. And then we're running this activate batch file. So when I do that, it's now here, and then just for fun, I'm just going to leave this open, and I'm going to do pip um, and there's this documentation for installing packages. So if you search Python install packages, you'll find this one. To install a requirements file, it looks like this: pip install -r requirements, the name of your file basically. So I'm going to say pip install -r requirements, this file right here, .txt, and there's just pandas in here, but that's going to install all the panda dependencies into. So we're getting NumPy, we're getting all these libraries that we need to use. So you can install all this without a virtual environment, and you can just do all the pip installs right on your main machine, but it's really nice to have the virtual environment so that all the dependencies are located in this project folder. It does make the project folder larger though. Okay, so we don't really need to have this expanded. Our our virtual environment is now loaded with pandas, and now we can go back to our demo. I'm going to close off my requirements folder. I'm going to import pandas, and I'm going to say my data set is equal to curly brace, and I'm making a dictionary: cars, colon, and then a list. So cars, really think of this as making a table. Cars is the column header, and then the data is the sequence that follows, i.e. this list. And so that will be my first item, and maybe I'll do it this way so that it's a little easier to read. So I've got two dictionary items. First key is cars, the second key is passings, 3, 7, 2. And so I've got, basically this is a table with two columns. One column is called cars with BMW, Volvo, and Ford. And then the second column is passings with 3, 7, and 2. And so then what I can do is, now that I have that dictionary, I'm going to make a variable assigned into it. I'm going to say pandas.data. I'm going to make a data frame. So we are the data frame is a class. In fact, this is a symbol for class in Visual Studio Code. And we're going to make our data frame, and in order to initialize our data frame, we're passing in this dictionary, which has our columns. So a data frame really is a table. That's all it is. It's got a fancy name, but just think of it as a table. And then I'm going to print this and see what it is. So let's run that. And okay, great. It worked. So we can also do this way. We can say import pandas as PD, which you see done quite often. Pandas is kind of a long word, and since we're going to be writing a lot, we can put an as in our input statement. This makes this an alias. So now everywhere we want to use panda, pandas, we don't have to type that whole thing out. We can just put PD, and it just shortens our code up a little bit since we're using this a lot. And maybe one thing we could do is say print PD dot version. You have some of these magic methods. This is version 1.3. That doesn't look great, so I'm going to do this. I'm going to make a format string and say pandas version. And there we go. We can see we've got this. Now, we're going to be using this in a very kind of, you're often use pandas in many ways. Another way you can think about it is pandas is basically an Excel spreadsheet and you have all the capabilities that you can imagine doing with Excel, you can basically do with pandas. So as far as manipulating a table of data, making new columns from previous columns by creating formulas, those types of manipulations, you could do those actually directly in an Excel spreadsheet and then just use this Excel spreadsheet if you're really good at Excel. But in this course, we're using pandas to do a lot of those manipulations for a couple reasons. One is that you'll notice when we bring in a file from the web, we actually often are downloading it from the web, and we're either bringing it down as a zip file and turning it into a data frame, or we're bringing it down as a CSV and putting it into a data frame. And then from then on, our code, if we do everything with code, with pandas, rather than manipulating it manually with Excel, whatever we need to do to manipulate that file to get it into the format we need, it can be automated. So here I made it as a Python program, but it actually makes a lot of sense to use this with a Jupyter notebook. And so let's set it up as a Jupyter notebook. So the way I can do that is I can add IPYND, I think it is. I didn't get the, let's see, Jupyter Notebook extension. So I want you to see what I'm thinking here. I couldn't remember what the extension was because there's too many things in my brain, and they just, sometimes you can't remember everything. So you just look it up. And let's see, I don't really care about all this stuff. I just want the extension, dot whatever. Okay, that's not going to be, let me find it quickly. Maybe I should say file extension. IPYNB, that's what I want. IPYNB. That's what I put wrong. There we go. Now it recognizes it. So now if we put an IPYNB, not D, we can make a Jupyter notebook. And now what I'm going to do is go back to my exercises and try them again, but I'm going to do it in the context of a Jupyter notebook. And so I'm going to import pandas as PD, print maybe so format string version pd dot version, and I'll run that. And it needs IPY. Okay, let's try it again. Did I use the wrong one? I did. I picked this first one. I need to pick the one in my virtual environment. And now when I run it, it's going to install that IPY kernel, which is needed for running Pandas applications. So when that comes up, just let it do its thing. Make sure that when you're running in Pandas, you are running off of your virtual environment if you have a virtual environment. Okay, it's saying it has no attribute version. That's because I forgot my closing ones there. Okay, so now it's working. Great. I'm going to close this. And now we're in Jupyter Notebook mode. It's kind of nice because you can write little snippets of code, and this is a great way to explore, libraries. So there we imported pandas as PD. That confirms that I am getting the version, and then I'm just going to add another code set, and by the way, you could also just, that has try yourself blocks in here, and you can do this directly in here, but I get more confidence when I'm using my IDE to try things out. So I tend to do it that way. This can be useful as well, especially if you're working off of a phone and you just want to go into W3 Schools and just play around with the technology to get a better feel for it. You have a few minutes waiting somewhere. You can open up your phone, go to W3 Schools, click on Try It Yourself, and it gives you a place where you can type some code and play around with it. But we're going to do it over here. The other nice thing about this is I can make notes next to it if I need to with the markup. So I'm going to use my notebook to do this. So I've already imported pandas as PD up here. So now I can do, maybe what I'll do is I'll put a markdown note here, and I'll just say series demos. And maybe I want, and then so maybe I will take some of these notes and place them as Panda series is like a column in a table. So we're going to make a list, 1, 7, 2, and we'll say my var is equal to, now normally you would want a more descriptive variable, but they're just using this to show generically what this is. And note that these are all classes. So series is a class, and to instantiate this class, what we're doing is we're passing in a list, a sequence of some sort. In this case, we're using a list, 1, 7, 2, and then we're just going to print it to see what we got out of it. So let's run that, and we can see that the way it displays it for us is we made a series 1, 7, 2, and now we have 3 elements with index numbers with the values, and it tells us the type is int 64. So it brought this in as integers. Let's see what would happen if I put point zeros next to it. This is why you want, Jupyter Notebook's kind of nice. Oh, look, that made it a floating point number. That's kind of cool. And what if I made this a tuple? Would it still work? So I'm making it a tuple. Yeah, it doesn't care as long as this is a sequence of some sort. Single, dimensional type of element like a list or a tuple. It'll bring it in. What would happen if it was a string? Would it actually handle it? Well, it does. It just brings it in as one element. That's not that exciting. So I'm going to go back to, I'll leave it as a tuple just to reinforce that it can be any sequence that's in there. So, okay, hopefully that, so we know that we can make a series. Let's see what else we can do. Then, so that's a series. The next thing we're going to make is I know it's pandas, so I'm just going to put data frame. And I'm going to suggest that we think of it as a table. And I'm going to add some code. And so I've already gotten my import pandas up there. And so I'm going to say data. And the way they're doing this is they're using a dictionary to make a data structure that has some columns. So each key value pair in this is really a column, because duration would be the column header, and then the values would be 50, 40, 45. Looks like some exercise data maybe. And once we have that, we can load data into a data frame object. So we're using the word object very specifically because data frame is a class, df is going to be our object, df, and we're going to use panda's data frame class to instantiate a data frame from this data object. And then if I print df and run this, okay, now you can see when we did a series, we just had one column. Our data frame now has two series in it by virtue of the way we set it up. It's just that rather than constructing it from a series, we made it with a data frame, the data frame class. So the next thing we could do is we can locate a particular row. Is really what we're talking about is if we wanted to just get a particular row, the loc gives us actually it's really column. Oh no, wait, I'm sorry. No, this is a row. So this does cut across. So when we say 0, we got 420, 50. If I say 1, I get 380, 40. So what I'm getting by doing this is I'm getting an individual element. Let's see. What I could do is maybe I'll do this. I'll put it in a variable. I'll say row 2 is equal to df.loc1. That would be row 2. I'll print row 2. Same thing. Now let's see if I were to print row 2 at index 0, what would I get? 380. Row 2 to index 1, what would I get? 40. So you can see, you could even do this, right? You could say df.loc 1, which gives me the that gives me, the second row. If I were to do this, get 40 both ways, because this one is here I've taken the row at index 1. This is the row at index 1. And I'm saying now, give me the element at index 1 at the row of index 1. What's the element at index 1? Calories is 0, duration is 1. So if I say row 2, index 1, I get the 40. Here I'm just doing it all at once. I'm saying give me the first row and give me the element at index 1. So this is the row at index 1. This is the element at index 1. It gives me the 40. So you can play around with that and just realize we can, if I wanted a column, let's see what would happen if I put that. I'll get a key error. Maybe they'll give us that next one. So our data frame dot I wish they'd use like yeah. Let's do this. Columns 0. Okay, so that gives me the column name. Column 0. If I say dot see what I want to do. Oh, that's interesting. You can convert it to Excel. So let's try this. Let's do print. I think I'm going to leave this like this. Oh no, I think that's kind of useful. I'm going to let's run that, and then let's add another code block. And let's print df.loc 0, 1. So what? Oops. So here I'm passing in a list with 0 and 1 in it. Let's run that. And now we can see that we are getting two rows out of this. We're getting the data for element 0 and element 1. If I were to put 2, I would get those elements. And I could put these in any order I wanted. And we can see that this allows us to maybe reshape the order we're looking at things, or get things in a different order. Or maybe we just want 0 and 1, and we're able to pull things out. You could also do this. Let's see. So I put this data into df. let's just print df just to make sure we know what we have. Okay, so we have our column here. What we could do is let's print. Let's do this. We will say df is equal to panda dot data frame, and we're going to pass in our data, which was this object up here that we created, and we're going to make that this a little different. We're going to say index is equal to, and we're going to pass in day 1, day 2, day 3. So 3 strings, and then we'll print df. So what does that do? So what you can see is that the 0, 1, and 2 have been replaced now, and this is now our index column. So, if you wanted to use a different approach to indexing your data frame or your table, you can do it. Just set the index attribute. If you don't provide the index attribute, if you leave it at the default, you get that. If you set the index attribute when you construct your data frame, you get those. And so now that we have this, what we could do is we could do something like this. We could say print data frame dot location day 2, and now when we want to find something, it uses this key to find the row that we want. So we saw how we can load a data frame just from a dictionary, right? So one way of making your data frame is with a dictionary, and just using that to construct it. We can change the index if we wanted to when we make that data frame. Maybe what I'll do is I'll copy this over. It's in scope, but maybe I'll do that just to make it complete. Another thing we could do is, let me add a markdown, and we'll say we can use a file to make our data set. So let me do this. We need a file to work with. We could download a file. I'm just going to maybe make a file. Data.csv is the name of my file. And, basically a CSV is maybe I'll put some numbers, 1.111. Actually, let's put some column headers in here. We'll say index, height, width, depth, and just some data elements, name. And so one, 10, 20, 30, volume 1, and then we have 2, 12, 23, 4, volume 2, and then 3, 21, 32, 43, volume 3. So hopefully that's properly structured file. Oh, Marketplace has something for dealing with CSVs. well, different viewers and stuff that are available. Don't think I want any of these right now, so I'll ignore that for now. I have my CSV file. It's kind of recognizing it as a CSV file. It's kind of cool. And so let's now pull in our, see how we can use this. So let me put this side by side, make some real estate in here. And then we already have pandas imported, so I'm just going to say df equals pd dot read csv, and then I need to put in the name of the file. In this case, I have to look where the file is located. Here's my, so since pandas, or since Jupyter Notebooks is going to, execution context will be where this IPY BNB file is right here. Data CSV should just be data.csv. And so, and then let's put that in, and then let's print df and see what we get. Perfect. It read it all in. It read my handwritten data file and brought it in just fine. And obviously this is, then they give you little exercises to remember. Did I get it right? Oh, what did I do wrong? P.read CSV. Oh, I think they want this. Okay, that was it. I figured it out. So there's several exercises in here. Yeah, actually, that's not bad. So let's see, data frame. The first row, loc 0. So I encourage you, go through those exercises. They will help you recall these elements. So they're very, very nice educational format here for this. And then reading CSVs. Okay, we already did that, it looks like, didn't we? Yeah, I read the CSV. Let's see what happens if I do a toString. Gives me the same thing. So the difference is if I, let's make this larger. We'll go in here, we'll go, and I'm just going to repeat this a few times. Four, 5, 6, 7, 8, 9, 10. Let's see, I got these off kilter. I mean, it's not really critical, but if I save my, now I've got my data file, which is a little bit larger, and I run this. If I do it that way, I get the whole thing. If I just print df, looks like it gave me all of them. That's interesting. I thought, it said by default you should only get the first 5 and last 5. Maybe I don't have enough data in here for it to do that. Let's put some more in. That might make it better or give us more. Wow, give us the whole thing. That's interesting. Oh, okay, no, that's what we expect. That one printed the whole thing. So it looks like it doesn't require me to do. Maybe it's just this version of Pandas works a little differently. Yeah, it doesn't quite behave the way it's saying it's supposed to here. So in any case, those are so. There's where we've learned how to make a data frame from a dictionary, and we've also seen how to make a data frame from a CSV, and then also how to set um, the column index names. Let me do this. I'm going to copy this. Got one more experiment I want to do here. And I'm going to make a data frame, but this time I'm going to make this be a just a simple list of lists and see what it does. I'm going to not set the data indices. And let's run that. So notice you can if I use a dictionary, the columns have names. If I don't use a dictionary, if I use a list of lists, it still makes the data. Well, two things happen. One is it'll make the table, but this becomes a row of data, and it doesn't have any names. Now, I suppose, let's see. Let's just put A and B, see if there's anything that happens with that. Okay, now it needs control. So I could also make a data frame this way, where now I'm setting the columns A, B, C. I'm putting in these are actually rows of data. If I want it to be organized the way this one was, I would actually do this. I would say calories and duration. And then here I would have to modify this a little bit. It would be 40, 50. be my first row. 38, 40 will be the second row. And 359, 45 would be the third row. So now I've I pivoted this. And so now I've got the same, we have the same data structures we had before, only I've made it a different way. I've made a list of lists, but then I set the column names, and then it lined it up. So that makes the same table as kind of this one. And then I could also do this as well. So I could, if I wanted the indices in this one, I would set that value as well. Why am I going and doing all these variations? Just to show that there isn't like a single right way of using pandas. There's a lot of different ways to construct your data frame. Once you have your data frame, then we can use it with scikit-learn to fit to fit predictive patterns to. So what you're using Panda for is to construct your your tables. So let's see what else do we have in here. You can also, they show you how you can use pandas to read JSON files, and then analyzing data frames. So there's a bunch of exercises in here as well, I would imagine. df info basically tells us what the data is in there. What the column types are. And then there's some tutorials in here about cleaning data. So if you had this data, so you notice here, okay, there's some empty cells, there's some not a numbers, there's there's some, this isn't a pristine piece of data. So what they go through here is, and we did some of these steps in the book. Read our data file, create a new data file from that, and you notice that there's this drop NA function. So that shows you that we can use that to drop, drop all the NA elements from the new data frame. And so I recommend going through all of these tutorials to just kind of play around and kind of learn more just generically how pandas works, so that then when you go back through the tutorials in the book, they make a little bit more sense. Let's see, correlations. Yeah, and so here we can see that, notice that duration column has 100% correlation with the duration column, which kind of makes sense. So that's why there's 100% all the way through here, or 1. And then notice, and then the rest of these are the correlate, how much do each of these correlate? So this can be very useful when you have some data and you're trying to pick which ones you want to use for linear regression. That's probably a pretty good calories and duration correlate very well with this exercise data. We got a pretty good strong correlation between pulse, max pulse here. We kind of expect that. And let's see, we have a pretty strong correlation between calories and duration. So, if we want to predict how many calories you're going to drop, duration would be a big factor in that. 0.9 correlation. Yeah, the longer you exercise, the more calories you burn. So, So those can be useful. And then we did some plotting, and here it's going to walk you through just all the different plotting methods that Pandas has, and then some quizzes. And let's see, yeah, a reference which has all these different functions that are there in more detail, which you can look at. So take a look at that, and I think that will help you understand Pandas a little better. Thank you very much.